In this video, we'll wrap up our quick look at the differences between the GS2 and the GS20 drive family's feature sets. The GS20 has 3 outputs, 2 digital and 1 relay. The GS2 has 2 relay outputs. The GS2's second relay maps to the GS20's digital output 1. So if you're using both relays on the GS2, you'll need to make sure that the GS20's digital output can handle the load. The GS20 also has a pulsed digital output, which can be used to monitor the drive's frequency or control other devices. Both drives have 1 analog output, digital and analog inputs, and a 10-volt supply for things like an external potentiometer. Having 2 analog inputs is a big deal because now you can use that second analog input to do summing, PID reference, offsets, all kinds of cool things. The GS20 also has a 24-volt supply, which can be used to power sensors up to 100 milliamps. And I love that the GS20 gives me 2 24-volt terminals. And remember that the GS20 uses these spring clamp terminals, and the GS2 drives use screw terminals, which can handle wire gauges up to about 12 gauge. So make sure your existing wiring will fit in the smaller GS20 spring clamp terminals, which can take up to 18 gauge wire. On the digital inputs, the GS20 has a lot more options for controlling the drive. The GS20 has an up-down option feature where you press an up or down arrow to adjust the frequency. Some people refer to that as an electronic potentiometer. You can even use a pulsed digital input to control the frequency of the drive. That means you can now have a master drive output a pulse train using that dedicated pulsed output that slave drives can use as a frequency source. That gives you a much more reliable system because you don't have to worry about analog noise messing things up. The GS20 also allows you to control the response time of the digital inputs and the polarity. The digital outputs on the GS20 have a lot more options, and you can control the polarity of those too. I really like that I can monitor the digital I/O on the GS20. Being able to see what the drive sees makes debugging my wiring so much easier. The GS20 has a lot more analog input functions, and while both drives allow you to change the bias and the gain and the polarity and monitor for signal loss, the GS20 also lets you filter and sum the analog inputs, and allows you to view the value of the analog input. Again, it makes debugging analog inputs so much easier when you can see what the drive sees. Both drives have a potentiometer on a keypad, but the GS20 gives you more control over the potentiometer value. The GS20 also allows you to modify the analog inputs using a 3-point curve. I love this feature because it allows me to linearize my analog inputs, which really helps things like PID. I can take a system response like this and use this curve function to turn it into a more linear response like this, which makes PID much more stable and accurate. The user manual has a bunch of examples that show you step-by-step how to use the analog inputs. The GS20 has a lot more analog output functions. Plus, you can modify the gain, the bias, and the polarity of the analog outputs, and you can monitor the value of the analog output. Again, making system debug so much easier when you can actually see what the drive thinks it's sending out. Both drive families provide 0 to 10 volt analog outputs, but the GS20 can also output 0 to 20 or 4 to 20 milliamps, and the GS20 is a 10-bit analog while the GS2 is only 8 bits. Both drives have multi-step, where you specify a table of frequencies you want the drive to use and select the frequency you want from that table using digital inputs. But the GS20 has twice as many available steps. The multi-step group also has 19 buffer registers for the PLC to use. That has nothing to do with multi-step, it's just where they ended up. Remember, you have 2 ways to talk to the built-in PLC. You can talk directly to the drive and directly to the drive's built-in PLC via Modbus RTU, but that requires that your system keep track of 2 Modbus devices in the same device, which can get confusing for your system. Or you can have your external device talk only to the drive and read and write to the buffer registers. The PLC then monitors and updates those. That keeps things much simpler for your system because your system thinks it's only talking to the drive and knows nothing about the PLC, which most of the time is just acting as a coprocessor augmenting the drive's functionality. Now, if you're using Modbus TCP or Ethernet IP, then you have to use this method because those 2 can't talk directly to the PLC. You can also use the buffer registers to collect random parameters into a sequential block of parameters. Now you can access them with a single Modbus command instead of issuing separate Modbus commands for each parameter. That saves you a lot of communications bandwidth. This is the same function as a GS2 block transfer. Let's do the PID section next because it relies heavily on this I/O. Your current GS2 PID parameters will transfer directly over to the GS20 because the default GS20 configuration uses the same dependent PID algorithm. But the GS20 also has the option of using a parallel or independent form of the equation, which is nice because you can tune each coefficient independently. Both can detect loss of feedback signal, but the GS20 can also detect when a deviation between the set point and the process variable is out of bounds. The GS20 also has a sleep mode, which is great for things like tank filling applications where PID doesn't need to run once the tank is full. The GS20 can also prevent PID from forcing the output to an undesired direction and can slow down the rate of the set point. This is especially helpful when a set point comes in over comms or multi-set point, so you don't get an instantaneous change that PID has to react to. The GS20 drives can take care of that for you automatically. The GS20 has a lot more set point and process variable sources, and a whole bunch more features that we'll cover in the dedicated PID tutorial videos. The special group has DC braking, controls how the GS20 deals with momentary power loss, and has DEB to intelligently manage deceleration when there is a power loss. There's a whole video dedicated to that topic. The GS20 allows you to control the operation of the fan to better optimize cooling and maintenance for your application. The GS20 has an energy savings mode, which backs off on the output voltage once the system's up and running and the torque is no longer required. That works really well when you have loads that aren't fluctuating or operating near full load. The GS20 has automatic voltage regulation, which limits the output voltage when the input voltage exceeds the motor's rated voltage. That prevents intermittent input voltage surges from heating up and damaging your motor over time. The GS20 has lots of torque and slip tuning parameters, which will be covered in other videos. And it has a function that detects when a load is out of balance, so the motor speed can be automatically adjusted to keep the washing machine or mixing machine from thrashing about due to uneven loads. The communication setup is straightforward, but of course the GS20 has a lot more options. Protections are also very similar, but again, the GS20 has a lot more options, including the ability to monitor an external thermistor, IGBT temperature monitoring, and safe torque off, which shuts down the drive completely independently of anything going on inside the drive. That's a huge safety feature that you just won't find on drives this price range. The GS20 also has phase loss and low current detection. It also has fire mode and a bunch more protections the GS2 doesn't have. The speed control group has all the parameters you'll need to set up the fancy speed modes that the GS2 doesn't have, and the advanced group has the parameters for setting up the adjustable speed regulation, torque mode, and PWM mode. We'll be covering all of those control modes in separate videos, so I'm not going to dwell on them here. Finally, there's a macro group, where you can simply select the application you have, and the GS20 will auto-populate the appropriate parameters with the proper values. This is a great way to get started quickly. Start out with one of these presets and add your motor's nameplate information. It takes a lot of the anxiety out of getting the drive up and running quickly for common applications. The parameters used are listed in the user manual, so you can see exactly the kinds of things you need to be thinking about for each application type. Well, that ought to be more than enough to give you a feel for the main differences between the GS2 and the GS20 drive families and what a huge value the GS20 is. It might seem crazy that the GS20 can deliver all of this at a lower price and a smaller footprint. But when you realize that GS2 has been building its reputation as an industry staple for 2 decades, and you realize how much microelectronics have changed over that time, well, yeah, it makes sense that the GS20 can do a lot more for less cost and size. Be sure to check out the GS20 Quick Start video. There's a number of things in there that will help you get up and running quickly. Meanwhile, click here to see all of the videos in this series. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's free award-winning support options.